Hi, my name is Roma and I'm a structural engineer, and one of my favourite types of bridges is the cable-stayed bridge, an example of which is the Millau Viaduct in France, and another one is the lovely Northumbria University footbridge in Newcastle, which was actually the first project that I ever worked on. So I'm going to tell you a little bit about cable-stayed bridges and tell you why they're quite complicated to design. So if you can imagine that you create this bridge deck, so I've just got bits of card and some rubber bands which I've taped onto the underside, and I've created two different little models. So the first model I've got here has quite a soft deck, quite a flexible deck, and then I've got these rubber bands here which are like the cables for the bridge. So if you're thinking about this bridge now, and I'm going to use these cables and the tension in the cables to hold the deck up, you can see that I need to tension up the cables in order to keep the deck flat. And if the deck is too flexible, actually that's quite hard to do. So if we try the second model now, where the deck is a little bit stiffer, I can now kind of pull on these bits of rubber band and actually create some tension to hold the bridge up. But what's quite interesting about it is that if you think about people standing on the bridge, and this certainly happens on my footbridge in Newcastle, because people stand on the bridge to watch people running below. So you'll get a lot of people standing on one side of the bridge. So what will happen is the bridge might tend to kind of twist in that direction, so the tension in the cables might change. And then as the runners go past, then it shifts back to the other side. So it's really important as an engineer for me to understand how much tension each set of cables needs, and to make sure that as people move back and forth, the cables never go slack like you can see there. So it's a really interesting form of bridge that you can read more about in BUILT.